Hello students, welcome to Board Maths Made Easy in English Medium. In today's video, we are going to learn Chapter 1 Real Numbers. It has three main parts. One is Euclid's division algorithm, second part is finding the HCF and LCM, and last part is proving the irrationality of numbers. Let's focus on part 1, Euclid's division algorithm. What actually Euclid's division algorithm states, any positive integer a can be divided by another positive integer b such that it leaves an integer quotient q and remainder r which is less than b. Remember, here we are dealing with only integers and that too only positive integers. As per the definition of Euclid's division algorithm, a can be divided by b such that it will have a quotient q and remainder r. So, how we can represent in a formula way is a is equal to bq plus r such a way 0 is less than or equal to remainder. That means remainder is always greater than or equal to 0 and always less than the divisor. So here I took a is equal to 23, that is a dividend, b is a 7, that is a divisor. So if I divide 23 with 7, the quotient I get is 3 and 7 times 3 is 21, the remainder left is 2. So in this case the remainder is not equal to 0, that means 7 is not a factor of 23. Okay, if you look into the important point, if a number a is divisible by b with the remainder 0 and b is not equal to 1 or a, then b is actually factor of a. Here there is a small typo, b is factor of a. So, in this case, I took another example, a is equal to 24, b is equal to 3. So, 3 divides 24, that is the value a, cleanly, leaving remainder 0. So here we call 3 is factor of 8, factor of 24. Why? Because it is giving a quotient 8 and remainder 0. So is that clear? And here how we can represent using the Euclid's division algorithm? We clearly said a is equal to bq plus r. See here, a is equal to b cube plus r and r is always greater than or equal to 0 and less than b. So, in case of a is equal to 24 and b is equal to 3, if we represent in the same formula, 24 is equal to 3 times q. Q is what? Quotient 8 plus remainder is 0. So, whenever the remainder is 0, the quotient is above 0 and divisor is not 1 or not same as the given number. In that case, this value here, the b value becomes the factor of a. Next, what is prime number? A prime number is a number greater than 1 that has exactly two factors, 1 and the number itself. Let us say I took a value called 17. Does it have any factor? Yes, I can write it as only 1 into 17 or 17 into 1. Here the order is not important, but the numbers are important. Here I cannot factorize it with any other thing, like 17 cannot be divided by any other number. So only the number 1 and the number itself. If this is the case, such numbers are called as prime numbers. Is that clear? So similarly, if I take another number, say 28, I can write it as 4 into 7 or I can write it as 2 into 2 into 7. Correct? Here, the factors are not just 1 and 28, okay, but it is not just 1 and 28, more than that, 2, 2, 7 or 4, 7. All those are all factors of the number 28. So such numbers are called as composite number. If you look at the definition of the composite numbers is a number greater than 1, see remember we are dealing in real number system with non-zero numbers and generally positive numbers. So in this case, and we know that 1 is not a prime factor. If any number is divisible by only 1 and itself, then that is prime number. Okay, it is not a composite number. A composite number will have factors more than 2, the number itself, and 1 plus other factors like this. If this is the case, then we call it as a composite number. So a composite number is a number greater than 1 and it has more than 2 factors. Note, 1 is neither prime nor composite. So if a number is divisible by, say 47 is divisible by 1. So what are the factors? 1 into 47. Here there is no other factor the 47 can made of. So in such cases, we call this 47 as a prime number. But if I take a 48, okay, 4 into 12, 6 into 8, like that we can divide with the other factors. Here just 1 and 48 are not the only factors, but other numbers are also factors. That means more than 2. More than 2 means what are the 2? 1 and the number itself. If these are the only two factors, then we call it as a prime. If there are more than two factors, like say here we can say 2 into 24, 4 into 12, 6 into 8, like that. Or we can say 16 into 3. So if there are more than two factors, you don't need to worry about all the number of factors available. But if there are more than two factors available, then the number is called as composite number. Remember, prime number definition is important. Prime number is divisible only by 1 and itself. Composite number is having more than two factors other than 1 and itself. If there are other numbers which can divide to give a number with the remainder 0, then that number is called as composite number. So here, whether a number is prime number or composite number, that part only we are going to understand in this particular video. So to quickly understand the divisibility rules, whether the number is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I have written only up to 12. If you have more accessibility to other factors, you can note down in the, as a continuation to this table. Let us understand the divisibility rules from 2 to 12. If a number is ending with 0, 2, 4, 6, 8, that means an even number, then obviously it is called as it is divisible by number 2. If a number, the sum of digits in it, like say if I have 216, so 216 means 6 plus 2 plus 1. If I add like 2 plus 1 plus 6, then it is 9. If this sum of the digits is divisible by 3, then the number is divisible by 3. Similarly, if last two digits in a given number are divisible by 4, let us take the same example 216. In the 216, 16 is the last two digits. So 16 is divisible by 4 and it gives a quotient 4 and remainder 0. So 216 is divisible by 4. So that is the rule for divisibility by 4. Next, divisibility by 5. If the last number is ending with 0 or 5, we know it, any number which is ending with 5 is divisible by 5. Similarly, any number ending with 0 is divisible by 5. Next, divisible by both 2 and 3, then only it is divisible by 6. So for a number to be divisible by 6, it should be divisible by 2. That means the number should be ending with 0, 2, 4, 6, 8, and also the sum of the digits. Okay, for 3 we know that the sum of the digits are divisible by 3. In that case, the number is divisible by both 2 and 3, and ultimately it is divisible by number 6. Next, for divisibility check of 7, okay, take the last two digit. Suppose any number like 16 is in this case, let us say I want to check whether the 216 is divisible by 7 or not. So what are the last two digits? 16. So double the last digit, not the double the last digit. In 216, this is the last digit. So if we double this last digit, it is 12, and subtract from remaining number. That means remaining number is 21. 21 minus 12 is equal to what? It is 9. Is this result divisible by 7? No. So when the number is not divisible by 7 like that, this is actually not a divisible number by 7. Suppose if I have reduced 216 to say 215, not even 215, I will say 200, and because I know this 217 is definitely divisible by 7. So what we'll do in this case, we double the last digit. So 7 into 2, 7 into 2 is 4, only this part 14, and from the remaining part we subtract this double digit, then it gives the value 7. So 7 is divisible by 7, giving remainder 0. So 217 is, we know 217 is 31 times 7. So we just verified in the reverse manner, so whether the rule like double the last digit and subtract from the remaining number, and the result whether it is divisible by 7 or not, to confirm the total number is divisible by 7. So this is the approach. Similarly, for 8, take the last 3 digits. Suppose if there is a number called 200 2248, whether this number is divisible by 8, last 3 digits divisible by 8. Okay, last 3 digits is 248. So if I divide this one, last 3 digits are 8 threes are 24 and 8 ones are. So that means last 3 digits are giving a divisibility by 8. So that means this number 2248 is definitely divisible by 48. If we want to know the results, I would say the divisibility by 8 gives us the approximately value 281. So this is 281 when I divided with the 8. Okay, so this is how you can verify the divisibility rules. So is it really need to know all these formulas? Definitely not. But if you want to find any prime factors, okay, or factors of a given number, so these rules will help us, and this is not part of our syllabus, but this we can out of our own curiosity we can learn to make it much faster solutions. Similarly, divisibility rules for 9, sum of digits. Here also we have done sum of digits. In case of 3 we have done a sum of divisible, all the digits should be divisible by 3, but in case of 9, sum of digits should be divisible by 9. Okay, next, divisibility rule for 10, last digit should be 0. If any number is say 210 divided by 10, obviously we will cancel out 0 0. So that means any number which is ending with 0 is divisible by 10. Next, difference for divisibility rule of 11, difference between sum of alternate digits. Like suppose if there is a 4 digits x, y, z, okay, and a. So alternate digits means this, the sum of these two digits plus sum of these two digits you take. So x plus z minus y plus a. If this is 0, if this result is 0, or if this is a multiple of 11, or if this difference is multiple of 11, like say 22 or 33, something like that it came, then this result, the final result, is divisible by 11. Yes, even 0 is divisible by every number, but 0 means automatically 11 will qualify in this particular case when you are taking the alternate position digits and adding them, and after addition if there is a 6 digits, say w v w x y z and a. So here v x z are one cluster v plus x plus z, and here w plus y plus a another cluster. So this cluster minus this cluster, if it is giving you 0 or multiple of 11. Okay, so in this case, remember, what if I get minus 22 or minus 33? Here, whether it is divisible by 11 or not, that's all we need to know. We don't worry about whether it is a positive number or negative number. If it is divisible by 11, then the total number is divisible by 11. And for 12, the number is divisible by both 3 and 4. For 3, we know that the sum of digits are divisible by 3. And for 4, what we know? The last two digits of the given number should be divisible by 4. If that both conditions are satisfied, then the given number is divisible by 12. Okay, can we do some samples? Can you say whether number 4 is a prime number or not? What we said, to know whether a number is a prime number or composite number, first try to do the factorization. If the factorization proves only the given number and one can only divide this given number, then that is a prime number. If it is a composite number along with one given number, there should be at least one more factor which can divide that given number. So in this case, I can say 1 can divide definitely, 4 will definitely divide, and also I can say 2 into 2. That means number 1, number 2. This is the third factor. Sorry, I think the video didn't cover that. So here 1, 4, 2 comma 2. So here more than two factors. More than two factors. That means this is a composite number. If I take 9, 1 will divide 9, 9 will also divide 9. These are the two factors. And what else can divide? 3 into 3. That means this is the third factor, and even though it is the same number, this is a fourth factor. So this number has more than two factors. See, whether the factor is same or not is immaterial. Here, more than two factors, then the number is composite. Okay. Similarly, suppose now I take another number called 13. Yes, 1 can divide the given number, 13 can divide the given number, but is there anything else that can divide 13? Nothing. That means you don't have any other number which can divide 13. So it has the factor as 1 and the number itself, no other factors. So this is called prime number. But I hope you are all understood what is a composite number, what is a prime number. Okay, in exercise 1.1, the first question is about finding the prime factors, okay, in each of the given numbers. So the first one is 140. We have clearly said any number which is ending with 0 is divisible by 10. Okay, and he didn't ask just express like whether it is a prime number or composite number. It is not the question. The question is find those prime factors. That means earlier we discussed, if you remember, the table where the divisibility rules, divisibility by 2, divisibility by 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here the number is ending with 0, we know that it is divisible by 2. And also whenever the number is ending with 0, it is divisible by 5. And also whenever a number is ending with 0, it is divisible by 10. So 2, 5, 10 makes are the factors. Okay, but are all of them at the same time factors? That we don't know. So what we can do is we can write 140 as, see, this is the smallest factor in this order. So 2 is the smallest, 5 and then 10. So if I write 2 140, how can I write it as? 140 is equal to 2 into 70, correct? So that is equal to 2 into, how can I write 70? Already I used 2 once I made it as a factor. In 70, now can I use another one like 5? Yes, 5 times 14, correct? And is it divisible by 3? No. 4? No. 5? No. 6? No. Of course, we can do with the 7, right? So 2 into 5 into 2 into 7. So that means it is 2 square into 5 into 7, correct? So this is how you need to write any given number as a factors, as a product of prime factor. So what is meant by product? When you are applying into mark between two numbers, okay, then that is a product. So here this is a 2, can we subdivide further as a different factors? No, because 2 is the prime number, because 2 has only 1 and 2 as a divisible factors, and 5 only 1 and 5, 7 only 1 and 7. So here what we have achieved by this kind of factorization, here we achieved a given number as product of powers of its prime factors, powers of product of prime factors. Suppose next one, if we take 156, okay, a number which is divisible by 2 usually will have 0 6 or 0 2 4 6 8, so it is definitely divisible by 2. And whether it is divisible by 3, we can do that. 5 plus 1 plus 6, it is 12 divisible by 3, so that is also possible. Is it required to always know this? No need. If you know the first possible factor, then you divide that number. Like say first 156, you can write it 2 into 78. So 78 is what? Is it divisible by 3? Yes. Then why? Because 7 plus 8 gives us 15. 15 is divisible by 3. So that is the reason 2 into 3 into 26. Okay. Again, can I write this further? 2 into 3 into 2 into 13. 2 13s are 26. So is 13 is a prime number, or is it has any kind of additional factors? It is not. So we will say that this is a prime, this is a prime, this is a prime, and this is a prime. So this is 2 square into 3 into 13. So this is now written as a product of prime factors. So next is 3825. We know one thumb rule. Whenever a number is ending with 0 or 5, it is divisible by 5. So definitely 5 is the factor. So I don't know remaining things, because we have to go and apply all that divisible rules. We don't want to do that each and every time. Just if we find first initial factor, there you will divide this into smaller chunk, and from that points you can apply if you require. Otherwise, if you know smaller number like this, okay, I know that 239s are 78, and 39 I can write as a 3 into 13. Then also you'll get, see, irrespective of the order, you get the same factors when you combine. Like when you written in the short format as a powers, you will get the same thing. Here I have written in the ascending order, like 2 is the smallest possible number whose power into 3 is the next smallest number, then 13. These are the only factors. So similarly here, in case of 3825, I can say it as a 5 times 35 is a 5 sevens 35, and 5 6 30, 5 5 25. So 5 into, so again here we have 5. So what we can say, 5 into 5 into 5 ones, 5 fives, 5 threes. So is this divisible by 3? Now you can check. Why? Because it's a small number. 5 plus 3, 8, 8 plus 1, 9. 9 is divisible by 3. So I will write it as 5 into 5 into 3 into 51. So this one, how can we write? We know it only one way. 5 into 5 into 3 into 3 17s gives 51. So how we will represent this? Here, how many squares? 3. Can I write 3 into 3 as 3 square, into 5 into 5 as 5 square, into 17. So this is the prime factorization for the value 3825. We have done this, we have done this, and this. Now for other two examples like 5005 and 7429, I hope you can do it on your own. Take it as exercise. And also 7429, what is the prime factors? Okay, so this is the method you have to write prime factors for any given composite numbers. So with this, the Euclid's division algorithm, it has given us a knowledge on prime numbers, composite numbers, and also it has given us prime factorization methodology. So I stop the video here. If you liked it, please subscribe. So we will continue the rest of the chapter in the next video. Good day. Bye.